So one force F1 is acting like this. The other force F2 is acting is, and the other force F3 is acting here. Then what is the torque set up by these forces about an axis passing through origin or about Z axis? We have three forces, no? How to calculate? So you do one thing, calculate the resultant force, torque about Z axis. I'm writing here, torque about point O about Z axis. So what is the method? Calculate the net force acting on the particle at point P. Then R bar cross F net bar. They'll give the resultant torque acting on the particle about an axis passing through origin or and parallel or about Z axis, you can see here. Now, what is F net? We know from vector concept. What is F net? F net is F1 bar plus F2 bar plus F3 bar. Let me substitute here. R bar R bar cross F1 bar. Go back to vector cross product. R bar cross F2 bar. R bar cross F3 bar. So how to, when a body is acted upon, when a particle is acted upon by more than one force. So what we are going to do, calculate torque individually due to each force. Take vector sum. You'll get the resultant torque. Or else what you should do, calculate the net force acting on the system, on the particle, then calculate F net bar and you know R bar, then one. So either of approach is going to help you. So when do this particular, you can do like this, only when the point of application of all the forces are same. If different points act at different point. So I'll give example. There's a formula, no? So always discuss with respect to a rigid body. Always take rigid body. Instead of, best example is the rod I started here. Now one force will act like this. It is making an angle θ1. The other force is acting like this here. And the other force θ3. The length of the rod is L. So now what is the torque exerted by these forces acting on the rod? You can calculate torque individually due to each force, then take the vector sum of those torques. Or else what you should do, you should take the resultant force. Now what is the torque due to 1? Now there's a different problem. Torque due to 1. Which component of force will set up a torque? Only F1 sine theta, L into F1 sine θ1. What about this sense? Anti-clockwise. Curl fingers from L bar towards F bar. L bar towards F1 bar. This will be L bar, no? The vector L bar will be like this. This is F1 bar. You have to curl it. You have to curl here. So I'll show that arrow, sense of arrow. You have to curl like this. And here you have to curl it from L bar towards F2 bar. Now, what about the torque due to other one? L F2 sine θ2. What about sense? Sense will be clockwise. Huh? So why here anti-clockwise, here clockwise? Curl, look at arrow. Rotate your fingers in the direction of θ2. Then what when the thumb will point into the plane, into the screen here. Better, shall I say? This will be tau 2. What about tau 3? This F3 sine θ3 or F3 sine 90 minus θ3. What is the angle between R bar and F3? So here F3 sine θ3 will set up a torque, no? L F3 sine θ3. What about F3 cos θ3 will intersect axis of rotation. F1 cos θ1 will intersect axis of rotation. F2 cos θ2 will also intersect axis of rotation. So we will set up torque. Only the vertical components of these forces. Sir, what about the sense of this? So should be again clockwise, no? Then I want the resultant torque. So the resultant torque should be tau 1 bar, tau 2 bar, tau 3 bar. The one which is anti-clockwise plus k cap, clockwise minus k cap. Substitute, you'll get it. Or else shall I do another method? I'll calculate the resultant force. Then L bar cross F bar. You'll get the same answer. The resultant torque, you can also calculate L bar cross F bar. And what is F bar? When this situation is applicable, when point of application of all forces are at a common point. If all the forces, the point of application is a common point. If the different forces act at different points, can we use still this formula? The resultant torque equal to this one. So here, I'll bring a new situation. You see now. You can take any rigid body. I'll just pick up a rod so that you can manage here. So force F1 is acting like this. Force F2 like this. And this is F3. Now, can we use the same formula? The answer is no, you can't. But the resultant torque you should calculate individually. But you cannot write this formula R bar. Sir, I'll calculate F1 bar plus F2 bar plus F3 bar. I think this is not applicable. No, any reason for that? The point of application of F1 and F2 is same. But what about point of application of F3 is different? So R will be different for these two things. No, R1 bar R1 bar will be L. R2 bar will be L. What about R3 bar? R3 bar, so let it be L by 2. I think can we use this formula? No, this formula is applicable when all the forces are having same point of application. If the forces are having different point of application, we should not use. Then, sir, how to calculate this? How to calculate? So what I do, I'll calculate individually due to each force. Now I'll resolve the component of force perpendicular to the rod. Torque due to 1 should be equal to Li cap cross F1 minus F1 J cap. In the vector form, I'm giving it. I cross J will be K, so this will be L minus LF1 K cap. Now torque due to second force, Li cap cross F2 sine theta J cap F2 cos theta 2 I cap. I cross J will be K L F2 sine theta 2 K cap. I cross I will be 0. Now what about torque due to this one? Tau 3 should be equal to L by 2 I cap cross F3 bar. What is F3 bar? F3 bar will be F3 cos theta 3 minus first high component, I'll write it. F3 sine theta 3 I cap F3 cos theta 3 minus J cap. Look at now, I cross I will be 0. I cross J will be K. So minus L by 2 F3 cos theta 3 K cap. Then what is the resultant torque? Tau 1 plus tau 2 plus tau 3. Fine. So whenever you take a rigid body, you have to check it, whatever the point of application of forces, or at different points the forces are acting. So better calculate individually torque individually due to each force about axis. First of all, you should know what is the axis. Axis is about point 2. So this is about, what is the axis? Passing through point O perpendicular to plane, or Z axis. if you define this as coordinate axis here, let me define that axis itself. So in every problem, you should identify what is that axis here. So is it justified now, Z axis?
Sir, when
Okay.
done. Sir, could you scroll up a bit, sir? Sir, here, top 3, how can we tell that it is clockwise, sir? Shouldn't it be anti-clockwise?
Simple, you take some rod and try to rotate, no?
Yes, sir, like from L bar to F3. From L to F3, right?
So there's an angle, no? There's an angle, no? There's L bar, there's F3 bar. There's an angle, you see? Angle is how much? 180 minus